We have seen this problem before when we talk about deterministic dynamic programming. Now let us modify the problem a bit such that now it becomes probabilistic. So in this problem, we must determine how many base fish to capture and sell. And then we will sell the fish with the price PT at the year T. And then we also have the cost to capture X base if the lake contains B fish at the beginning of the year. So it's still all deterministic. Now the uncertainty comes when it says here, the base in the lake multiplied by a random factor D, where the probability that this factor equals exactly something like a small d is QD. So big D, you can think of this as the set of all possible values of D, and then the small d is just one instance of one specific value of multiplication factor. Okay, so QD is the probability that the fish will be multiplied by small d. Now we would like to formulate a dynamic programming recursion to maximize the owner's net profit. Okay, as usual, you may want to pause the video to read this problem carefully. For this problem, the stage is quite obvious. The stage is the year, so we have year 1 up to year 10. So 10 is the big T, or the very last stage of this problem. The state is the number of base fish in the lake at the beginning of the year. It is denoted by B. And the decision is the number of base fish to catch during the year T, and it is denoted by X. Now here's the formulation for the stage T. Big T equals 10 because it is the very last stage of this problem. So F10B is the maximum net profit that can be earned during year T, year 10, if the lake contains B base at the beginning of year 10. So if we have B fish at the beginning of the year, and then we decide to catch X of them, then we may get the revenue of X times P10, because P10 is the price of base fish at the year 10. Okay, so this is our revenue from selling the fish that we catch. And then minus the cost of catching X fish, given that at the beginning of this year we have B fish in the lake. Okay, and then do not forget to say that the allowable decisions is between 0 and B, and we would like to maximize this profit that we obtain among all possible decisions. So among all x, and then x must be between 0 and b, we would like to find the x that maximizes this function. In other words, we would like to find out how much fish we should catch such that the revenue is maximized. And do not forget this aspect 1, the fish that you catch must be greater than or equal to 0, must be less than or equal to b, less than or equals to the fish that you have at the beginning of the year. So let us formulate the recursion function for stage t, and the t is small here because it is less than 10. Okay, so ft means the maximum expected net profit that can be earned during year t, t plus 1 up to big T, if the lake contains b bays at the beginning of year t. Same as before, we get the revenue from selling the fish that we catch. So x is the fish we catch and pt is the price of fish at year t. We sell those fish, so we get the revenue of x times pt. We also experience the cost from catching the fish, which is depending upon how many fish we have at the beginning of the year. So we experience the cost of ct x given b. Okay, and also same as before, the number of fish that we catch must be greater than or equal to 0, must be less than or equal to the number of fish that we have at the beginning of the year. So up to this point, and this is aspect 2, the aspect 2 is still pretty much straightforward and similar to what we have seen before in the stage big T. Now let us talk about the aspect 3. Now let us talk about what happens at the stage t plus 1, and this is about the aspect 3. Now here it says that if the fish are multiplied by the factor of d, it means that this thing here, ft plus 1 d times b minus x, is the maximum expected net profit that can be earned during year t plus 1 up to big T if the lake contains d times b minus x base at the beginning of year t. So remember that b is the base that you have at the beginning of this year. X is the number of fish that you catch this year. So the remaining fish in the lake is b minus x, what you have at the beginning of the year, minus what you catch this year. And then next year, they will be multiplied by the factor of d. So next year, you will have fish as many as d times b minus x. However, the d here is probabilistic. Remember that in the problem it says that the probability that a particular value of d will happen is qd. And that is why you need to multiply it with the probability of d happening, which is qd. Remember, as I've talked about in the previous video, the key in the probabilistic thing is that when you see something like this, if the fish are multiplied by the factor d, then you need to always multiply this with the probability that d is happening, right? You say here if multiplied by d, it means that you need to multiply it with the probability that d is happening. That's why you see qd times that, okay? And then you need to take the sum for all possible values of d. Because d, the small d can be several values that are possible to happen. And then you have several values of d that can happen. So you just need to take the sum of them. Let me give you some numbers to make it more concrete, okay? Let's say at the beginning of the year you have 100 fish in the lake, and then you catch 12 of them. So at the end of this year you will have 88 fish left in the lake, right? Now let's say if D equals 0.9, it means that next year you will have 0.9 times 88 fish, such that you will begin next year with the state of 0.9 times 88. If D equals 1.2, you will begin next year with the state of 1.2 times 88. If D equals 1.4, it means that you will begin next year with the number of fish equals to 1.4 times 88. Okay. So in the previous slide, we have seen that we may start next year with that number of fish, that number of fish, and maybe that number of fish. But do not forget, in the sentence, there is this part, if. So we need to translate this if into the probability. So we may start next year with this condition, if D equals 0.9. And D equals 0.9 happens with the probability of Q0.9. That's why you need to multiply it with the FT plus 1. If D equals 1.2 means you multiply it with Q 1.2, and then if D equals 1.4, it means you multiply it with Q 1.4. Remember that QD is a function. It doesn't mean Q times D, but Q is a function of D. Okay, and then we need to do that again because if you read the sentence, it says if D equals this, then we will begin with that number of fish next year, and so on. Now let's make up some numbers again. Let's say Q0.9 equals 0.10, Q 1.2 equals 0.79, Q 1.4 equals 0.11. And then we replace those Q's with the probabilities. So it means that with probability 0.10, our expected net profit for the year T plus 1 until the end of the problem is this. And with probability of 0.79, our expected profit for the year T plus 1 until the end of the problem is this. And with the probability of 0.11, this is our expected profit for the year T plus 1 until the end of the problem. Remember, if we have several events that may happen, then what we need to do to summarize them all, to get the expected value of them all, is to take the sum of them all, right? So you take the sum of 0.1 times this, plus 0.79 times that, plus 0.11 times this, which becomes the expected value for stage T plus 1 until the end of the problem. So let's generalize that. Suppose we say if the fish are multiplied by D1, we will start the next year with D1 times B minus X fish, such that the revenue from the later stages, T plus 1 until the end of the problem, equals FT plus 1 D1 times B minus X. If the fish are multiplied by D2, this is our revenue from the later stages, FT plus 1 D2 times B minus X. And then so on until we have Dn, then this is our revenue from the later stages. Remember that if we have something like this, if this happens, if that happens, if that happens, we need to multiply it with the probability. So probability of D1 is happening, which is Q D1. The probability of D2 is happening, which is Q D2. The probability of Dn is happening, which is Q Dn. And then because everything here can happen, we take the expected value of all these events by taking the sum of all of them. So multiply this, multiply that, and then take the sum of them all, such that y, you see the sign sigma here, and then there is the small d underneath the sigma. It means that we take the sum for all possible values of these. Or in other words, the sigma actually means something like this. Q d1 times ft plus 1 d1 times b minus x plus Q d2 times ft plus 1 d2 times b minus x plus until the end Q dn times ft plus 1 dn times b minus x. But because writing this is very long and you don't really know what is the n number here, you don't know whether n is 3, 4, 5, 6, 10, 100, 11, or 1100, 11,000, or whatever number. So that's why we just summarize it into sigma here. So don't be confused with the symbol here. It just means that we take the sum for a lot of possible values of d that we don't know yet how many possible values of these that we may have. So we just write down sigma with the symbol d underneath the sigma. So this week we have seen the calculation to solve the probabilistic problem using probabilistic dynamic programming. We have also seen two examples on formulating the recursion functions, and that's the end of this week. And next week we are still going to look at a few examples on how we may formulate the recursion functions. So thank you for watching and see you next week.